In the grand scheme of things, an elimination reaction is essentially the reverse of an addition reaction. We start with a reactant that is saturated, we remove two of the constituents, and we end up with a product that is unsaturated and with a byproduct. Right? So if this was an addition reaction, it would have made sense if this arrow was flipped around. These would be the reactants. This would be the product. But it's not. So in the elimination reaction, let's look at how it happens. So what we're going to do is we're going to take our saturated reactant, in this case we have ethane, and we're going to gloss over some details here, but what's going to happen is these two hydrogens, or two of the components on the ethane, are going to be removed. And so as they are removed, these two hydrogens are going to want to form a new bond with each other, which they'll do like so. So that's one of my products. And in the process as well, there's going to be a double bond that's formed between these two carbons, which is going to give me ethene, which is unsaturated, as my one product, and in this case, hydrogen as my second product. What does this look like on paper? So we can tell it's an elimination reaction because we're removing atoms. We're starting with one reactant, and that reactant is saturated. So the only reaction that we can do here is an elimination reaction. And like we talked about, these hydrogens here are going to leave. It's a multi-step process, but the overall reaction is that those hydrogens will leave, will form a double bond between the remaining carbons. So we have ethene as one of my products, and my second product is going to be hydrogen, or H2, which is these guys bonded together. In this elimination reaction, instead of starting with ethane, we're going to start with ethanol. So you can recognize that this is ethanol because it's got a hydroxyl group over here. Now, if I have ethanol, it's going to be much more likely to leave when the double bond is formed than these hydrogens over here. So it is going to become part of the product. And in order to form a double bond here, we have to remove something from this carbon, which is going to be the oxygen. We also have to remove something from this carbon, which is going to be this hydrogen. And so when you take the hydroxyl, the oxygen and the hydrogen, and this hydrogen, and you put them together, well, then you get water, which is why we have water as our second product here, in addition to the ethene as our second product. So let's look at the reaction. Here's my starting material. Here's my reactant. It is saturated, right? Because it's got a single bond between the two carbons. It's got a hydroxyl over here. So the big picture thing that's going to happen during the elimination is that the hydroxyl is going to leave. It's going to take this hydrogen here with it because they're sitting right next to each other. So they're going to want to leave together. And when a new single bond is formed between the hydrogen and the oxygen, we get water. And then a double bond is formed between these two carbons, like so, which gives me my unsaturated product as well, my ethene. So I can recognize it as an elimination because I have an unsaturated product, whereas I started with reactants that were saturated, right? The ethanol was a saturated reactant, and I have two products. I have my water and I have my ethene as my two products. So like we said, the hydroxyl here is going to leave, be eliminated, along with the hydrogen that's sitting next to it. So it's these guys here that are going to leave. They're going to form water. And my other product is going to be the remaining atoms, but we now will have a double bond present between the two carbons. So we're getting ethene as a product again. In this case, though, we have water as a byproduct instead of hydrogen. And that's why this reaction is also called a dehydration reaction, because water is removed during the process of the reaction. So in this elimination, we're starting with chloroethane. Instead of a hydroxyl here like we had in the ethanol example, we have a halogen. Similarly to the hydroxyl, the halogen here is going to be much more easily removed. It's going to want to leave more so than these hydrogens over here. So it's going to end up leaving the molecule when we form my ethene product. And as it leaves, it's going to take this neighboring hydrogen along with it, which is going to give you the second product of hydrogen chloride.